All right. Good morning, everyone, or good afternoon, depending on what time you're watching the video. Today and the next several days, actually, we're going to be taking a look at special right triangles. So there's a lot of information in here. We're going to do a whole lot of different examples to make sure you're following along, you're taking notes, re-watching videos, and doing your practice problems that are on campus. So let's get started. There are two special kinds of right triangles. So the first one is a 45, 45, 90 degree triangle. So the theorem says that in a 45, 45, 90 degree triangle, the length of the hypotenuse is the square root of 2 times the length of a leg. So let's fill in. We got our right triangle over here. Let's put our right angle mark in here. So that's my right angle mark. We know that across from here is your hypotenuse. So according to the theorem, it states that if this is a 90 degree triangle, right triangle, which it is, this is 45 degrees. And this is 45 degrees. That's why the name of the triangle is a 45, 45, 90 degree triangle. So if this is 90 degrees, this theorem is telling us that this is 45 and 45. So I have a 45, 45, 90 degree triangle. It tells us that the legs are the same length. So this leg length is X and this leg length is X. So I do not know what these numbers are. I just know that if this is 5, that's 5. If this is 11, this is 11. If this is 20, this is 20. So my leg lengths are the same. According to the theorem, the length of the hypotenuse is the square root of 2 times the length of a leg. So the length of my hypotenuse is the square root of 2 times whatever this number is. So if this is 7, my hypotenuse is 7 square roots of 2. If this is 20, my hypotenuse is 20 square roots of 2. So in 45, 45, 90 degree triangle, your legs are the same. And then this side, which is your hypotenuse, is the square root of 2 times the leg length. So let's go down here and then do these 4 examples so that we will make sense of what this theorem is telling us. Example 1, find the missing lengths. So this is 90 degrees. These two are the same. So we know that they're both 45 degrees. So since I know that this is a 45, 45, 90 degree triangle, that means I can use this theorem up here. So I know that if this side is 4, this side has to be 4 because of this theorem up here. So X and X, your leg lengths are the same. So if this is 4, this is 4. The theorem says that the hypotenuse is X square roots of 2 times that amount. So my hypotenuse is 4 square roots of 2. Whatever these two numbers are, you put that in front of the square root, and that is the length of your hypotenuse. So this is a theorem that's been proven and derived long before we were ever here. Centuries and centuries ago, it is proven in a 45, 45, 90 degree triangle. Your legs are the same, and your hypotenuse is X square roots of 2. All right, B. Tick marks mean that these two sides are congruent. So if this is 10, that's 10. And our hypotenuse is the square root of 2 times our leg length. So 10 square root 2. Example C. Example C actually gives us the hypotenuse, so we can kind of work a little bit backwards there. So I'm going to show you how I like to break it down. So I know first that this is a 45, 45, 90 degree triangle. So this is my 90 degree, that's 45, and then that's 45. So we are dividing this 8 by the square root of 2. So I'm dividing it by the square root of 2. I'm going to do a little bit of work down here because this one requires just a little bit more work than the other ones do. So this is what I know. X square root of 2 equals this length here. That's what I already know. So X times the square root of 2 equals 8. So if you're trying to get X by itself, because if I can figure out what X is, then I know my leg length here. So this is X times the square root of 2. I can divide both sides by the square root of 2. So this gives me X equals 8 square root 2. Now, to be simplified, you cannot have a square root in your denominator. So I have 8 divided by the square root of 2. To be simplified, you cannot have a square root in your denominator. So let me grab a colored pencil here. We're going to do something called rationalizing the denominator. That just means if this is the square root of 2, we're going to multiply both the top and bottom by the square root of 2. So I multiply both the top and bottom by the square root of 2. So on top, 8 times the square root of 2 is what I have left. And on the bottom, the square root of 2 times the square root of 2 is 2. Feel free to use a calculator, mental math. It's going to cancel out. The square root of 2 times the square root of 2 is 2 because they cancel out. And then 8 divided by 2 gives me 4. So my final answer here is 4 square root 2. So I had to do a little bit more work than I did for the first two, because the first two I was looking for the hypotenuse as opposed to C where I was given the hypotenuse. So if you're given the hypotenuse, you can take this, what is equal to, which is the x square roots of 2, and you can set up an equation and solve. So my answer for this is that my leg lengths are both 4 square roots of 2. So this leg length is 4 square roots of 2. And then this leg length is 4 square root 2. And the last one for this 45, 45, 90 degree triangle, this one over here, I know that, again, I'm giving my hypotenuse. And I know that these are both 45-degree angles because they're the same. You don't have to label, but there's nothing wrong with labeling, especially since they're going to be two different kinds of triangles. So this is a 45, 45, 90-degree triangle. I'm going to do the same thing. I'm going to set up an equation. So I know that this is equal to x square roots of 2. So I know that x times the square root of 2 is equal to my given hypotenuse, which is 7 square roots of 2. Now, this one worked out way easier than C because I got a square root of 2, I got a square root of 2, I got a 7 here, so this x must be 7. So the length of my different sides, 7 and 7. So that is a 45, 45, 90-degree triangle. The other kind of special right triangle is a 30, 60, 90 triangle. So the first one we looked at was 45, 45, 90. The other kind is a 30, 60, 90 triangle. So this theorem says that in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg, and the longer leg is square root of 3 times the length of the shorter leg. So, of course, pictures always help. So let's go ahead and put in our 90-degree angle. All right, this is what the words is telling us. It's telling us that I have a 30, 60, 90 triangle. So I'm going to say that this one's 30 degrees, and I'm going to say that this is 60 degrees. All right, so baby step, working our way through this picture here. The length of the hypotenuse is 2 times the length of the shorter leg. Now, this is 30. Directly across from 30 is the shorter leg. So again, this is 30 degrees, go directly across from there. And that is going to be our shorter side. Excuse me. That's going to be our shorter side. And so this is 1. Across from 60 is our longer side. And the longer leg is the square root of 3 times the length of the shorter leg. So this is 60. Go directly across from 60. That's going to be our longer leg. So that side is x square root 3. So 1 is the shorter leg. I'm going to label that shorter leg. And across from 60, if I draw an arrow directly across from there, that is going to be our longer leg. And we know directly across from our 90-degree angle is our hypotenuse. And according to our theorem here, it says the length of the hypotenuse is 2 times the length of the shorter leg. If the shorter leg is 1 times 2, my hypotenuse is 2. I am going to redraw this triangle without all the arrows so you can see a little more clearer. My point to that was to show you that across from the smaller angle is the smaller number. 60 is the longer leg, and then we already knew that across from the right angle is the hypotenuse. So if I redraw this without all the arrows, it's telling us that this is 30 degrees, this is 60 degrees, okay. This side is 1, this side is 2, and then this side is x square root of 3. So we're going to use this triangle to go through and do several examples so that we have plenty of practice to look at. So this is a 30, 60, 90 degree triangle. So 30, 60, 90 degree triangle. The shorter side is 1. The longer side is x square roots of 3. And then opposite of that is your hypotenuse, which is 2. So let's start with the first one. So this is my right angle. That's 30. This must be 60. Must be 60 degrees. So we're going to go through and label some things that I know. I know that the relationship between the shorter leg and the hypotenuse is twice as much. So if my shorter leg is 2, if I double it, it'll give me the hypotenuse, which is 4. And I also know my relationship between my shorter leg and the longer leg is that I just multiply it by the square root of 3. So if my shorter leg is 2, this leg is 2 square roots of 3, because all we do is incorporate this ratio, which is the square root of 3. Okay, B. Again, label, label, label. Nothing wrong with labeling. If this is 60, this is 30. I know the relationship between my shorter leg and the hypotenuse is that the shorter leg that I'm tapping down here, that's across from 30, my shorter leg is half of the hypotenuse. So if the hypotenuse is 10, I can find this by dividing by 2. So this side is 5. And I know the relationship between my legs is that the longer leg is the square root of 3 times longer than this. So this is 5 square root 3. Right? C, label, label, label. This is my right angle here. So if that's 30, this is 60. Okay, things that I know. This 60 corresponds to the longer leg. So this is the longer leg. So I know my relationship between the longer leg and the shorter leg is that you just multiply the longer leg by the square root of 3. So if I get rid of the square root of 3, that means that this side is 8. Because when I multiply it by the square root of 3, I get 8 square roots of 3. I know my relationship between the short leg, which is 8, and the hypotenuse is that if I take my short leg and multiply by 2, it'll give me the hypotenuse. So short leg multiplied by 2, 16 is the hypotenuse. Okay. D, I know that if this is 30, this is 60. Okay. This is my shorter leg. 7 is the shorter leg. My relationship between the short leg and the hypotenuse, the short leg multiplied by 2 gives me the hypotenuse. So this is 14. My relationship between the short leg and the longer leg is that I take the short leg and I multiply it by the square root of 3. So this side is the square root of 3.